Now we go to example 2 for high frequency response. This question asks you to determine the GM out and GM. Find AV and AVS in mid-frequency range. C. Determine FH in and FH out. D. Determine the cut-off frequency. E. Sketch the high frequency response using butt plot. So refer to this figure. Okay, there is values for the CW in, CW out, CGD, CGS, and CDS. Okay, notice that in this circuit, the CGD, CGS, and CDS is not sketched in this area, but you must know where is CGD, CGS, and CDS. Just remember the name of the terminal. CGD located at G and D here. CGS located here, G and S terminal, and CDS at D and S. Okay. Then another information is IDSS 6 milliampere and VP is negative 6 volt. In this video, I only give you a final answer for the question A and B because you can solve this question using AC and DC analysis. Okay, so here GM out is 2 millisiemens, GM is 1.17 millisiemens, where the IDQ is 2.07 milliampere, VGS is negative 2.48 volt, and B, the AV mid is equal to the AVS 1.98. For this example, I only focus on the high frequency response, the input and output, and how to sketch the asymptote and also the actual curve. This is the solution for question C. Determine FH in and FH out. I start with the FH in at the input side. First, calculate the capacitor input. Okay, C in. So C in equal to CW in plus CGS plus CM in. Okay, the CM in, now the CF is the CGD. When insert all values, then you get 20.92 picofarad. Next, calculate the RTH, the impedance. Okay, equal to RC parallel with RG. So insert value for RC and RG, and we get 999 ohms. And finally, calculate the FH in using this equation, 1 over 2 pi RTH in, C in, and substitute all values. So you get 7.62 megahertz. Next, we calculate the FH out at the output side. We repeat the step, calculate the C out. So C out equal to CW out plus CDS plus the CM out here. Then for the C out, you get the answer is 12.02 picofarad. And the impedance at output, RTH out, equal to RD parallel with RD and parallel with RL here. So insert all values, so you can get 1.7 kilo ohms. Final equation for the frequency is FH out equal to 1 over 2 pi RTH out, C out, and substitute all values that we calculate earlier. we get 7.79 megahertz. For question D, determine the cut-off frequency. Now, we compare the value of FH in and FH out. The smallest value is FH in with 7.26 megahertz. So the higher cut-off frequency is FH in. Next, we go to the question E. Sketch the high frequency response using Bott plot. So for this one, we need to find the asymptote by using the approximate analysis equation. So this is the equation. Okay, remember that the difference between the low frequency and high frequency is at the frequency. For the high frequency is F divided by F2. For the FH in, the voltage gain, we insert the FH in value is 7.62 megahertz. And for the frequency here, okay, can you see in this table, I said the frequency is in megahertz. So you don't have to calculate the megahertz inside this frequency. Just the numbers 10, 100, 1000 and so on. So just leave this part of the megahertz. So here you can take 10 divide by 7.62 megahertz, and then when you calculate this, you get the AV is negative 2.36. For the FH out, insert the FH out value here 7.79, and then for the frequency here, we insert this value 10, and then 10, then you calculate, you get the AV is negative 2.17, and this one 100 divided by 7.79 mega, we get the AV is negative 22.17.